Hey folks, welcome to Engineering Scale Models. I'm Jason, your host, and I do models and apparently electronics. Hey, what's up with that? Alright, today we are going to be looking at a few things and that I received in. We're definitely going to get the meter off the screen. Okay, so I'm still new at this live streaming thing, so bear with me while I adjust some things here. I can't see my chat. Okay, there's the chat. It doesn't tell me how many viewers there are. Oh, there we go. Now it seems to be working. So, okay, so we got that working. So I got some stuff in the mail um, for randomest things. So we're gonna open it and see what it is. I don't remember because it came from China. So I ordered something so long ago. It's like I can't remember what it is. So let's see here. Let's open this up. This feels like another component book here. That's what this feels like. Yeah, it looks like a component book. I would have to say, from what I'm missing, it's the 805 resistors or the 805, yeah, the 805 resistors or the 603 capacitors. That's it. It's either one of those. So let's see here. They really pack these things, don't they? It looks like a resistor book. Hey, Coder, how you doing? Yeah, it's 805 resistors. Yeah, that's what I thought. So what I'll do is I'll open this up here. I need a new blade on here. It still works. So yeah, this is 0805s. It's a book full of various resistors in Chinese. So, you get to learn Chinese and solder on tiny components. So, yeah, so that's what learn Chinese and solder on tiny components. So, that's what this is for. It'd be nice if there was like a table of contents, but you really literally got to flip through this book to find what you're looking for. It's just like, that's a little insane to me. And there's a spot, this is 170. It's not populated. I wonder if somebody's actually gone through here and checked all these to make sure they were correct. Oh wow, it looks like there's like 2 strips of each resistor. That's pretty good. Some of the books only have 1 strip of stuff. But I guess it seems like the resistors all have 2 strips of stuff except for the 1206s. I don't remember what they had. So that's got to have a label put on it. I'll do that. I'll do that later, and I will put it to the side for now. So, let us see what's in this box. This might be something of interest. I doubt it. Oh, look. Oh, is it a package in a package? Nope. Okay, so it is really folded up in there, like weirdness. Okay, you see in this, right, they're just like wrapped like drugs. Okay, they're Joy-Con batteries. Actual Nintendo Joy-Con batteries. I had gotten some of these, and they were knockoffs. They were knockoff Nintendo batteries, so I paid a little extra for these, but I don't like to send things out with non-Nintendo knockoff batteries. So I believe I got these for because I bought 3 packs of 2. They come in 2 to a pack. I believe I paid like $3.89 or $4.89 or something for two batteries. So you can get them cheaper that aren't Nintendo, but they're, I don't know. I don't like that. So Nintendo Joy-Con batteries for the Joy-Con repairs. They will go in the parts drawer. Now in the parts drawer. And we will open this last one here. I wasn't even planning on doing a video on opening packages. These just showed up yesterday. Like 9 o'clock at night these showed up. My wife's like, hey, you got a bunch of packages. I'm like, it's 9. Why am I getting packages at 9? But that's how late the mail can come. Okay, so this right here is packages of Joy-Con screws in springs. All the screws for a Joy-Con, so 5 packs. Now, if you buy 5 packs of these screws, they're 89 cents a pack. So that's why I have the excessive amount of 5. Because it was like, I got like 1.5 free. So I was like, okay with that. And, you know, I don't mind having the screws. And these are the actual switch screws. Little bags of switch screws. And I think these are $1.29 if you buy 4 or more. So I got some of those. So I'll have to go in the screw bin with the other screws. I keep those sorted in my little parts bin here. See, I have all the different screws here and where they go. And then I have my chips and whatnot in there. All that good stuff. So, little parts bin there. I wonder if my chat is refreshing because I'm not seeing if anybody's typing anything. Oh, I'm getting some kind of warning. Yeah, I don't know how to do anything with this chat. Let me see something here. Hold on 1 second while I just pop a window up here. Okay, let's do it this way. Alright, that seems better. So I didn't like that preview window they give you when I set it up. So okay, so that's what we got. We got some screws, some Joy-Con batteries, and a book of many thousands and thousands of resistors. Okay, so what I was working on yesterday with the Nintendo Switch is this is a known good switch right here. So this one is a known good switch. It works. Just the USB port needs to be changed. I mean, the USB port works perfectly fine, but it just needs to be changed. And I'm going to be doing that soon. But before I do that, I wanted to take a bunch of diode readings. And I took diode readings off the USB port, the battery management chip, and the M92 charge control chip. So I put them all in a spreadsheet form. And now I have them so I can check my other one to see if the diode modes match. So I still have to do the P13, so I am going to do that now. So I am going to come in here like so. This one's going to be tricky with all that capacitor so close. Okay, so pin 1 is there, so I don't even know if I'm going to be able to do this. I'll use it all 3 screens today. Okay, so if I show you this here on there and take that off. Okay, so you see here, this is the BQ2419 chip here, and that is the M92 chip, and that is the USB-C. And now we're going to do the P13 USB chip. So let's get my probes here. Let's put let's put on the meter this time and activate the meter. First, I'm going to put the meter in diode mode. There we go. So I'm going to clip my red probe here on ground. And I'm going to start probing this. First, I'm going to give you the microscope view. And no microscope view. Plug in the microscope, then you can have microscope view. All right. There we go. Now we have the microscope. Okay, I had to unhook it yesterday. So if we go there, and apparently we lost the meter, so we're going to take care of that right now and bring that up here. Meter, and we also lost our pad. There we go. So I have this all set up. So what I'm going to do is I'm going to select this section in here. So what is that? How many pins wide is that? That's 1, 2, 3, 4, 5, 6. So I'm going to go shift 1, 2, 3, 4, 5, 6, and then we'll just go about this far, and I'll make that black, and then we'll pull that down about there. Okay, so this right here is pin 1. That's pin 1, and I'll make this look better. So we're going to start up here on this side of the chip right here. So Make sure we're not touching anything else. So 4.59. So 0.459 over. So, and I'll make it look like the other one. First, I'm going to turn that beep off of. Oh, I can't turn it off now. Okay, the beep's off. Okay, so why is that still 0.459? There we go. All right, next pin. This is going off to a. Awesome, just do it the same way you did the but it'd be able to come off easier though. Okay, that's cool. Yes, hello to everyone out there, and thank you for joining the stream. Okay, so we have. Okay, so we're on pin 2. This next pin here. So 0.474. 0.474. Okay, next pin. This doesn't take very long, but you guys get the idea of. See, I'm touching that capacitor, I think. Oh, I wasn't touching the capacitor, so that's 0.44 or 0.439. Now, see, this trace goes from this pin here to this, so I can touch that capacitor. So 0.459. So the next one goes to the capacitor next to it. So I touch that side of it. 0.452. And then this one is this little guy right here. 0.442. 442, and then we have these two little guys out here. 447. I think most of these are all going to be the same because they're filtering the output. And then this one here. 0.441. Okay, so I've done 1, 2, 3, 4, 5, 6, 7, so 8th bit over. 5, 6, 7, 8th bit over. 0.448. And the next one is this one here. 0.441. Okay. And then the one after that. 452. Okay, so I'm just going to finish up this one side here. Actually, I'm not going to finish up that one side. This is extremely boring and taking forever. The diode readings for the pins going to the filter should be pretty close together. Yeah, I'm getting that on there, and they're all 0.45 something. So I am going to. I didn't think The other chips I did took me like 3 minutes to do. This one's taking longer than I thought. So I am going to put a battery on this. Let me get my battery. I'm going to put my battery on this. And I want to see what voltage is present on this back side with the PMIC. This this area, where is it at? Right around here. Well, not, because these are definitely inductors, right? The big ones are definitely inductors. Yeah, I know. I realized it. I'm going to move on and do it when I'm not making a stream, so I can concentrate. So I just want to check these right here, these inductors here. So I need to go to ohms mode, which continuity will do. Alright, so I want to check to see here. So this, yeah, that's an inductor. Okay, that's what I wanted to make sure that was an inductor. So I'm going to take my black probe and I'm going to clip it to the USB-C port. And then I'm going to plug my battery in. Okay, so I'm going to try to get as much of this in shot as I can. Okay, so if I plug my battery in on a good working switch, this right here is the, and put me on voltage mode here. So voltage. That's what I want. Okay, DC voltage. So yeah, I thought they were inductors. So if I put my probe here, I should get, okay, I got 3.8 volts, which is what's the power of the battery. So this is by the battery management IC. So I should be getting 3.8 volts there with the unit not powered on, just a battery hooked up. And I want to see what rails are present on the back of this thing to by this power management IC over here. I want to see which one of these inductors have power and which ones don't. So that one has nothing. 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 Wow, this thing really has no power until it's powered on. Wow, that's weird. Okay, there's a power management IC here. Is there any power here? No. Down here. Well, if that's the case, that this thing is completely shut down unless with the battery plugged in, except for this power management circuit, that's pretty insane unless there's power management under these shields, which I'm definitely not taking off. Yeah, Coder, do you know if there's shields under, like inductors under the, or like power management sections underneath the shields? Yeah, I was hoping there was like a zero point 0.9 volt rail. Yeah, just RAM and CPU. I was hoping there was like a 0.9 volt rail that they used for, you know, like a sleep mode type of thing. But It's not in sleep mode. It was actually physically turned off. But man, that is a hard turn off to only be having this battery charge circuit here drawing power just to boost this up, to probably, like you said, go right to the power button and then short it to ground. Or because if you look here, this is the fan and this is the power button. If you look by that power button, there is some resistors, and I bet you, because you have volume up and down on this rail too, but I bet you one of these resistors pulls one of these pins high, and when it's pulled low, that's when it turns the power on. So we could probably probe in here and check this resistor here. Nope. There it is right there. There's the 3.8 volts on this resistor, and I'll bet you it's going to be pulling it. That this is a 5-volt rail, or your power rail right here. And that's going through the resistors. But if you see there's 5 volts, 3 volts on that, which is the battery power, and it's going right into one of these pins of here. So it's probably going to short that to ground, and that's how you're going to get power. Yeah, I don't want to do that though. I'm going to stay away from doing that, because I want to stay away from doing that. I don't want to short it to ground, so I'm going to unhook the battery. So wow, that's actually extremely low power consumption for a standby circuit. That's crazy. That's the kind of stuff I like to look at to see, what all is drawing power in a circuit, and to have this battery management IC, which is going to be real low current, and just a teeny tiny resistor pulling this pin up. There's really no voltage anywhere. You could probably see, I'm going to be making a battery connector out of an old battery, and I'll be able to see the current draw put on the battery to see what the quiescent current of the switch is, what its standby off mode current is. So, but what I'm going to do now is I'm going to put this good board up before I make it a bad board. So I'm going to put that up in my, oh, hold on, you got to see this. Let's take that off, and we'll take that off and that off for now. Now, look, check this out. This is a storage bin. It has storage for the switch and the little thing of screws and a lid, and then a little lid up here to put this in there. $1 for Walmart. Keeps everything together, and it's got a label. Look at that. Not going to misplace anything or lose it on my bench. Well, I'm old, so that's cool. I have no problem with being old. It's called experience. If you're young, you don't have any experience. You haven't learned anything yet. So, this is the bad one, so I don't even know why I'm opening this nasty mess. Okay, so I did find an issue that I wanted to address on a stream, because I changed that M92 chip on a stream, and I may have discovered a problem with it, and I want to share it with the stream here. So let's go back to this. No, not that, not that. And all these are labeled, I still get it wrong. Okay, I need to put the scope down like this. And is it this side? Oh, that's not even the right chip there. So there's my M92 chip right there. That's one side that's soldered, and you know, I'm not thinking that's too bad. And then let's see if I can get this one in view. See this side right here? This looks a little unconnected and dodgy to me. Yeah, you see that? That looks poorly soldered. And then this side looks okay-ish. But let's check this side here. Where would that give me a focus on? See, that one, I don't know. Hold on. My hand's shaking, sorry. But you see, that looks a little dodgy on the soldering too. What do you think there? Yeah, reflow in the joints with the iron. With Lewis Erasmus reversal flux, yeah. I don't have to use that much with the flux I use. So, but we're going to do it anyways, so. Oh, here we go. For the sake of this video, I actually have some Amtech flux. So, see, this is what I'm talking about. Like, I can see more than you can see on the screen, on my screen. It's a little bit different on what I can see. I see a little bit more. Okay, so we're going to actually get out Lewis Rossman flux and spill shit everywhere. So this is that Amtech garbage that I can't stand. But we're going to flood that shit. Look at that. See? Lewis Rossman's amount of flux. And this time, I'm going to use my TS100, T100, whatever it's called. I'm going to use with this tip here. Ooh, that's a good tip. Ooh, that's a good tip. I like that tip. Okay. I'll plug it in first. This thing heats up super fast, guys. Alright, so now, should I add some solder? No, I'm not putting, no, it's exactly, it's expensive. I'm not putting more on. Yeah, this one, this one hasn't been updated to the firmware. It does get to 450, but it doesn't tell me how much juice is coming to the soldering iron. But the charger says 19 volts at 2.1 amps. So it's the charger it came with. It's one of those Toshiba chargers, I think. Excuse me. Should I add a little solder or should I just reflow it? Yeah, add a little tip. Okay. That's what I was wondering. Just waiting for that piece of advice. Okay. What's that sound? That's the sound of fume extraction. Okay. Now let's see if well, let's focus the damn thing. now this is the tricky side here. These other sides aren't too bad. Okay, so let me go back to that angle I had it on before. And let's see here. We can. So that one looks good, I guess. Yeah, I know you have a fuel extractor, you don't use it. See? Look, why are they still looking dodgy? Is that just my shitty microscope or what? Why do they look like they're not connected? I don't know. What do you think? They're connected from the bottom? Okay, so it looks better though. It definitely looks better. Alright, we can turn off the safety first fuel extraction. Or at least in the top 5. You know, safety doesn't have to be number 1. As long as it's in the top 5, you're good. Alright, I'm going to pop a little bit of this good old stinky flux remover on here. Oh, should be fine. Plug in the charger and check the voltage on the caps on the right side of the chip. Also the opposite side to where you're looking. Okay, will do. Let me get me a cloth and my brush and some IPA now. Oh, you know what? You guys can't see what I'm doing. Oh, not that one. There. I am cleaning off the flux of the board. This is a chem wipe, which are free to me. And I'm brushing it with a soft bristle brush and some IPA to get all that sticky, crappy Amtech expansive flux off. Okay, so plug in battery, charger, and see what the voltage is around. Okay, so I'm going to change the view on this. So, okay, so this is going to be the view if I check anything on this. You want me to check the caps on the top? You know, what side do you want me to check the caps on? I'm getting the charger now. If you notice, when I get anything, I have to put it back away when I'm done with it. So, I'm super weird. Okay, so we have the charger here. Nintendo charger. Actual Nintendo charger. Actual Nintendo battery. So, I'm hoping this is the problem here. So, we're going to plug in the battery. And then we're going to plug in the charger. And we are getting 500 milliamps like we did in the past. And you want me to check the voltage around the caps. Right side of your view. 2 caps in a line. So check the voltage. I could do that. It's on voltage. Okay, apparently, hold on. There we go. Okay, what's up? Those are output caps going to the battery IC. Okay, so these right here are 1.3 volts. That seems incredibly low. And that's millivolts, and that's... Oh, that's ground. Okay, now I'm not getting anything off of that cap. Oh, you know what? I must have been touching this test probe down here. No? Okay, do I still have voltage at this? Yeah, I still have 3.8 volts at the battery management IC. Yeah, I don't think that's right. I shall get... Oh yeah, if you're sitting there with a switch doing nothing but watching this, might as well. But there was like 3 volts. Oh my god, dude, listen. Now it's only drawing 24. It's not drawing any current from the charger now. It's basically given up altogether on the charger. Yeah, it's not even drawing the 500 milliamps anymore. It's not even charging the battery, and the battery's not fully charged. The battery is at, well, I just check it on this right here. The battery's only at 3.8 volts, so the battery's not fully charged, and it's no longer charging. So I think it's going to be that P13 chip, or something just blew my M92 chip, which would super duper piss me off. I'm going to go to continuity mode. Oh, not that button, this button. Interesting situation on this one here. if I take this third pin, let's take a diode mode reading here, because if I take the third pin here and I come over here to this chip here, and I put it on the screen. If you look at this chip here, and then I come over here and I put my red probe on ground, and I measure, pin 3 on this side. So pin 3 on this side here. I get very fluctuation there. So never mind. It was just weird because this cap right here is not giving me a reading on either side of it in continuity mode. I have to take some medicine. Give me a second. Oh, I shorted something. It can't be a broken switch. I've had to short it. Okay. Yeah, you're probably right. I guarantee you that's what I did. Yeah, everything's already been disconnected for like 3 minutes. Okay, so let's plug it back in. And see what we get. No, it's not. It's drawing the 23 milliamps. It's drawing nothing because the meter actually draws that much current when it's running. So it's got nothing on that. So, yeah, everything was disconnected for like a minute, if not longer. And I have battery voltage on the coil over here, down here. I have battery voltage on there. I checked that already. But yeah, I don't know if you can see that meter drilling nothing. But we can definitely say I fixed it, in quotes, more. That's what I did. I fixed it more. Because it had that problem to where it was drawing 500 milliamps, and then I was like, oh, I fixed that. Now it doesn't want any milliamps. So boom, fixed it. No, seriously, this switch has been just a nightmare. In being the first switch I got, I thought it was going to be an easy couple swaps of the chips, and I'd be in business. But after changing 2 chips and a USB-C port, I have gone backwards because it was reading better. So, okay, on the top cap down the right outside. Yeah, there's not going to be any there's not going to be anything there because if I put that there and we are in voltage, if I touch that right there, I'm not going to get anything. The other side's ground, so oh, top cap, my bad. Nothing on that side. Nothing on that side. And like I said, it's drawing no current. It's actually shut off the current meter. Shut off. Yeah, it actually shut off because it was drawing no power. So, I'm not sure. This is a weird one. The diode readings seem normal on that M92 chip. And why all of a sudden would it not want to charge the battery anymore? So, yeah, I might have killed the M92. I'm coming to that realization. I think I did kill it, or technically I fixed it. Fixed it. So I did not quite kill it. Okay, let's not jump to any conclusions. If anything, we're saying I fixed it. In quotes. Oh, wow. Okay. So, I'm going to put my power meter up in my testy box. I'm going to disconnect my battery before it makes this one a bad battery. And put that back in its box. I'm working on a location for my batteries. Battery storage. Okay, so it has been an hour, and I have to take an online class today in digital logic and design. So I am going to get started on that before anybody else gets up. And I am going to... Here's what I'm going to do. I am going to stream me changing the M92 chip yet again, and then the P13 chip. I'm going to do both those in a row and test it and see what happens. And if it doesn't work then, I'm going to pull those chips back off and save them and keep them as good chips, because I think I'm just going to say this is a dead board and I can pull parts off of that for another switch that I knock off components or something. So I think that's where we stand. On your minute, do you want to put the known good readings for those 4 test points too? Yeah, I'm gonna do the test points on the board on a separate section in the spreadsheet thing. If you see, the spreadsheet has different, if I can find it, has different tabs. Like there's the USB port, there's that one, and it has different sheets for each one. I'm gonna do test points too. I got other things I'm working on, so I'm actually gonna put the Switch aside for 2 days. I got 2 classes in school I got to get done, and then I'm going to work on the Traffic Light project and the FPGA. So I hope you guys have a great day. Thank you for stopping by, Coder. And if you watch this later, guys, I hope you can leave me some good comments on what was going on there. But thank you so much. And if I could find my mouse, I can stop the stream. I really can't find my mouse. There it is.